Welcome back to All This Math. This is Professor Parker, and for this lesson, we're back doing some Eureka math. So we're doing some math from the Eureka curriculum, and today we're going to get into some grade 6 work, or some 6th grade work. We're going to be in Module 1, Lesson 20. Module 1, Lesson 20, which deals with ratios and proportions and unit rates. This is a very critical concept in all of mathematics. It's a very critical concept just in life in general, because we need to understand unit rates, we need to understand ratios, and we need to understand how ratios relate to each other in the form of proportions, just in everyday life, whether you're shopping, whether you're trying to understand your paycheck, or different things of that nature. So what I'm gonna do now is, from the Eureka textbook, right? I'm not going to write out, as you can see, I didn't write out the entire problem on the board, but you're following along from the Eureka curriculum anyway, so you have access to that. We're doing problem letter D. So I'm going to read it, right? I'm going to read it, and you can follow along wherever you're watching this from. So letter D says, Mr. Steiner needs to purchase 60 AA batteries. 60 AA batteries. It's a lot of batteries. A nearby store sells a 20-pack of AA batteries for $12.49. And it also sells a 12-pack of the same type of batteries for $7.20. That's your background information. Now, 2 questions I asked within letter D. The first question is, would it be less expensive for Mr. Steiner to purchase the batteries in 20 packs or in 12 packs? Let's read that again. Because again, with word problems, you want to read the information over and over again until it really sinks in and until it really starts to really make sense. So number 1, would it be less expensive? So we're trying to find out what's less expensive. And that makes sense because as a consumer, you don't want to spend the most money, right? You want to spend the least amount of money, right? You want to get the most for your money. That's what that's called. Getting the most for your money is when you spend the least amount of money for a product or a service, right? Would it be less expensive for Mr. Steiner to purchase the batteries in the 20-pack or the 12-pack? So these are the decisions we got to make. So we got to do some problem solving, right? So we got to understand mathematics so we can make the best buy and get the most for our money. So this is a ratio and proportion problem. Well, a proportion is just when you have a ratio equal to another ratio, right? So ratio and proportion, we kind of can use those terms interchangeably. So this is what I would do in this problem. First of all, when I deal with word problems, I want to think of a scenario, right? To make the word problem more real. Let's say Mr. Steiner is a middle school teacher. And Mr. Steiner, he wants to do a Xbox tournament. And he's going to bring in a whole bunch of Xboxes. People are going to bring their controllers in. He wants to make sure he's got enough AA batteries for everybody, right? That could be one scenario. Or let's just say he's a brother that just wants to make sure he got plenty of AA batteries in his house. You never know what could happen. Maybe the zombie apocalypse or something. I don't know, right? He just want to make sure he got a lot of AA batteries. All right? Maybe just for his TV remote controls, the remote controls for other things that he uses in his life. Who knows? But I bring that up because you want to become very comfortable with the word problem. So you want to think about the scenario, like what's really going on, right? Who is this guy, Mr. Steiner? Why does he need all these batteries? You know what I mean? Like, because that makes the math problem easier, right? It makes it easier when you start to really break it down. All right. Now, again, they got a 20-pack. So imagine, try to visualize that. Visualize what a AA battery looks like in your head, right? And then imagine 20 of them, a pack with 20 of them in there. And then another pack has got 12 in it. Now, some people might make the mistake and say, well, he said less expensive. Number 1 said which option is less expensive. So I know that $7.20 is less than $12.49. Don't make that mistake. That mistake comes from not really understanding the question. Keep in mind, Mr. Steiner don't need to buy 20 batteries. He don't need to buy just 12 batteries. Mr. Steiner needs 60 batteries altogether. 60 batteries altogether. Now, the company that makes the batteries, I don't know whether it's Energizer, Duracell, whatever the company is, it don't matter, right? They either put them in packs of 20 or packs of 12. So if you got a pack of 20 and you need 60, you're going to need more than one pack, right? Because 20 is less than 60. Even if they got them in packs of 12, right? If you need 60, you're going to need more than one pack. The question for us is, how many packs are we going to need? All right, and which arrangement is going to be less expensive. So let's set up our proportion. All right. Let me grab my marker. Now let's deal with, let's create a ratio for the 20 pack. All right. So what we're going to do is, this is how we're going to set up our ratio. And a lot of ratios in these problems are going to be set up this way. All right. In these types of problems. What we're going to do is we're going to have quantity over price. Quantity over price. And that's not the only way you can set it up. That's just how I choose to set it up. You could do price over quantity if you want to. But I'd rather do quantity over price because it's a certain amount of batteries for a certain amount of price. And when I read in terms of math language, I go from left to right or I go top down. So if I'm doing quantity for a certain price, reading it left to right, then if I was converting that to a vertical fraction, I would also go top down. That's the only reason I do that. So let's look at it like this. So write this down in your paper. Quantity over price. Quantity over price. All right, quantity over price. Now, that's a ratio. Now, we need to set up a proportion. A proportion is just a ratio that's equal to another ratio. So that's going to be equal to the same thing, right? Quantity over price. All right. Now, what we're going to do is we're going to set this up we're going to set up a proportion for the 20 pack, right? And then we're going to set up another proportion for the 12 pack. Okay. And it's going to look like this. Now, because when we read the problem, we remember that a 20 pack costs $12.49. So quantity is how much of something you have. That's the amount, right? So we're going to replace the word quantity with the number 20. Draw your fraction bar, and then the price of a 20 pack was $12.49. So we replace the word price with 12.49. Then we're going to put our equal sign, and then we got to put information over here, right? We got to replace this quantity and replace this price. Now, this is where we put the information we're trying to figure out. The question is, which would be less expensive? And he needs 60 batteries. He needs 60 batteries. He don't need 50 batteries. He's not trying to find out information about 75 batteries or 40 batteries or 100 batteries. He needs 60. 60 is a quantity. 60 is a quantity. So in this ratio, instead of writing 20, because we're trying to find out about 60, you put your 60. And now the question is, so what should go down here? The price. If we read the problem, that's what we're trying to find out. So whenever we do math or algebra, more specifically, when we're trying to find out a value that we don't know, we pick a variable. And you can use any letter of the alphabet. It don't matter. Let's use P. P stands for price. So this is our proportion, which is also an equation. It's an equation because we got an equal sign and we got an unknown value. Well, it would still be an equation even without the unknown value, but we could use this equation to solve for the unknown value. Now, this is our proportion. This is the hardest part. We just finished the hardest part. The hardest part was setting this up from the beginning. 20 batteries cost $12.49. Now that's equal to 60 batteries, which cost a certain price. Now the reason that these fractions are equal to each other is because there's something called a unit rate, right? Each individual battery costs the same amount based on the fact that it's 20 in a pack that costs $12.49. So what we're trying to do is find out what price makes these fractions equal to each other. What price is going to make these fractions equal to each other? Now, if the 20 got bigger, the $12.49 is going to get bigger, right? Now, one way real quick looking at this, you can answer this problem is like this. Look at the relationship between 20 and 60. 20 is 1/3 of 60. Or you can think of it as 20 times 3 equals 60. So in order for these fractions to be, or ratios to be equal to each other, they have to have the same relationship between the numerators and the denominators. So if 20 times 3 is equal to 60, then $12.49 times 3 should equal the price of 60 batteries or 3 packs. That's one way to do it. All right. Now, if you go to your calculator, you would do, I could try it. You would do 12.49 times 3 and you would get the answer, right? Well, that's not the final answer to number 1, but that's an answer that's going to help you get to the final answer to number 1, right? Because you still got to do it for the 12 pack to find out which of those two answers are, those two dollar amounts are cheaper, right? Or less expensive. You know what I mean? So 12 times 3 is 36. 40 times 3, 40 cent times 3 is $1.20. 9 times 3 is 27. So 36 plus $1.20 is 37.20. 37.20 plus 27 is 37.47. So $37.47 should be the cost of 60 batteries. But let me show it to you algebraically. All right, I call this the Malcolm X method. Whenever I deal with proportions and I'm solving a proportion, I'm solving for a variable, I call it the Malcolm X method because I form an X, right? This is also called the cross product property. See the X I just drew? I do this number times this, and I also do this number times this number. So 20 times P is going to be 20P. So I write 20P down. Then I bring the equal sign down. Then I'm going to do 12.49 times 60. And that's why I call it the Malcolm X method, because you see that X right there, right? And plus you need to remember Malcolm X. So that's why I like to bring that ancestor's name up, right? So we got 20P is equal to 12.49 times 60. So now I'm going to grab my calculator to do this math real quick. So I got 12.49 times 60. That's 749.4 over here. And then I bring down my 20P. And I'm trying to solve for P. So whenever you're trying to solve for a variable, you're trying to isolate the variable by itself, right? So you're trying to get rid of 20. So the way to get rid of 20 is to do the opposite operation from what 20 is doing. 20P means multiplication. That means you got to do the opposite of multiplication, which is division. So we're going to divide by 20 on the left side, but because it's an equation, you got to divide by both sides. So divide this by 20 also. 20 divided by 20 is just 1, so they cancel out. That's just going to leave you 1P, 1P, and 1P is just P. 1P and P mean the same thing. Then on your calculator, 749.4 divided by 20, do that, and we get $37.47, which I already told you was going to be that, right? See, the beauty of that is you see how there will always be multiple methods to get to an answer in mathematics. Always. It will always be multiple methods. And you just pick the method that you want, unless your teacher specifically tells you use this method. But it's good to know multiple methods. All right, so basically this is saying if you buy 60 batteries, if Mr. Steiner bought 60 batteries out of 20 using 20 packs, he'd have had to spend $37.47. Now, Mr. Steiner wants to know, okay, well, what's cheaper? Should I do the 12 packs or should I do the 20 packs? So now we're going to use the same proportion, right? Now we're going to do for the 12 packs, we're going to do 12 over, and a 12 pack costs $7.20, right? So we're going to put 12 over 720 because it's quantity over price. And then I'm going to do, my quantity is still 60 because I'm trying to find out how much is 60 batteries going to cost if I'm getting 12 packs, right? If I'm doing 12 packs, how much is that going to cost? My price, I just said how much is that going to cost, so I don't know the price. So that's going to be P. Again, I'm going to use the Malcolm X method again. Draw my X. 12 times P, and you don't got to put the 12P on the left side. Sometimes you can put it on the right side. I just like having my variable on the left side. That's just my twist, you know what I'm saying? That's just what I like to do. I like to have my variable on the left-hand side. So 12P is going to be on the left side, and then over here I got 7.20 times 60, just like the last problem. See how we keep doing the same thing again? Math is all about rhythm, right? You know what I'm saying? Math is all about rhythm. Once you catch the rhythm, you can do any problem, all right? So then 720 times 60, back to my trusty calculator. 7.2, because the zero don't really matter, times 60 is 432. So that's going to become 432. Bring the 12P down. Now, how you get rid of this 12? How do we get rid of this 12? The same way we got rid of this 20. 12P means 12 times P, so we got to do the opposite operation. Opposite of multiplying is division. So we're going to divide by 12. On the left side, we're going to divide by 12 on the right side. Boom, boom. 12 divided by 12 is 1. So that's 1P. It's 1P, right? 1P, so that's just P. Then you go back to your calculator, unless you know that off the top. 432 divided by 12, I don't know it off the top. It's 36. So that's 36. So now, look, we just use math in order to make an appropriate decision as an educated consumer for Mr. Steiner. So Mr. Steiner, he wants the least expensive option. So now you look at your answers and say, okay, well, which number is smaller? $37.47 or $36? 36 is less. So we want this option. So we grabbing 12 packs. We grabbing 12 packs, right? So we're gonna grab the 12 packs, right? And then we gotta say, okay, now, how many 12 packs? if you're trying to get 60, right? All you would do is 60 divided by 12. I mean, the book doesn't really ask this question. I don't think it does, unless I've neglected to write that part of the problem down. But 60 divided by 12 is 5. So that means 5 12 packs is cheaper than 3, because 20 times 3 is 60, cheaper than 3 20 packs. Which is kind of strange, actually, because there's something you're going to learn about called economies of scale. When you have a bigger volume, usually the companies make it cheaper for you. But for some reason, this worked out like this. I don't know. But anyway, I ain't going to fight about it. But yeah, so the answer to number 1 is, and you should always write, when you're dealing with word problems, you should always write your answer in a complete sentence. So you would say, it would be less expensive for Mr. Steiner to purchase 12 packs. 12 packs. So don't be one of them people. I know a lot of people just, going to write the answer. They're going to say 12 pack, right? But do yourself a favor. Get into the habit of writing complete sentences. All right? Get into that habit if you don't already have that habit. Don't be lazy. All right? So it would be less expensive for Mr. Steiner to purchase 12 packs. All right, that was number 1. So let me write this over here. That was number 1. Now, that was number 1. Now, let's talk about number 2. I got a little bit of space left, and I can answer number 2. Number 2 asks the question, what is the difference between the cost of 1 battery from each pack? What's the difference between the cost of 1 battery from each pack? So in number 1, we was trying to find out how much 60 batteries was going to cost. Now we're trying to find out how much 1 battery is going to cost from each pack and then compare the 2 costs. So basically, we're going to do the same thing. We could use the same proportion, the same one, right? Except instead of putting a 60 right here, we don't care about 60 batteries no more. Now we care about 1 battery. We care about 1 battery now. So basically, all you're going to do is replace your quantity of 60 with a number 1. So everything else is going to be the same. Like, you're going to have, for the 20 pack, right? Like, if I want to know how much 1 battery costs in the 20 pack, basically, I'm just breaking the 20 pack down. I'm taking $12.49 and I'm breaking it down into 20 equal parts. That's what division is. You divide something up into equal parts, right? So I got $12.49 and I divide that up into 20 equal parts. And each of those parts is the price of 1 of those batteries. Why did I divide by 20? Because it's 20 batteries in the pack. If it was 15 batteries in the pack, I would do $12.49, divide that up into 15 equal parts. If it was 30 batteries in the pack, I would take the $12.49, divide that up into 30 equal parts, because each part is 1 battery. That's what division really is. That's the essence and the concept behind division. All right. So now let's do this. Let's figure out how much is 1 battery off that 12 pack. So we got 20 over 12.49, because that's quantity over price, is equal to quantity over price, 1 battery over, let's say, X. Let's call that X. All right? Because we want to find out the cost of 1 battery. Now, I'm going to just go ahead and just do this using, again, Malcolm X method. Boom, 20 times X is 20X. 1249 times 1, anything times 1 is just that number. So we got 20X equals 1249. 20X equals 1249. Now I'm going to get X by itself, so I got to get rid of that 20. We doing algebra right now. We solving a simple equation right now. I got to get rid of 20. How do I get rid of 20? I got to do the opposite operation. What's the opposite operation? Is division, because 20X is multiplication. So I got to divide by 20 on the left side, divide by 20 on the right side. Boom, 20 divided by 20 is 1, so I got 1X. 1X is just X. Then I go back to my calculator again. We're going to take this $12.49, break it down into 20 equal parts. 12.49 divided by 20 is point. Now we got to know how to round. You got to know how to round, because watch this. 0. We talking about money right here, right? Like, you never went into the store and bought something that cost $6,245. We ain't doing that. We ain't doing that. You got to know how to round. Round it to 2 decimal places. Round 0.6245 to 2 decimal places. So this is your second decimal place, right? You want to round to the 100th place. 6 is in the 10th place. 2 is in the 100th place. So you always look to the digit to the right of the place that you try and round to. When we buy stuff from the store, right, it's 2 digits in that. It's either 65 cents, 50 cents, 35 cents, 25 cents. 2 digits, right? So this number to the right is a 4. 4 is less than 5. So that means we round down to 62 cents. Because when we round it, we only got two options. We either going to round down or round up. So we either going to round down to 62 cents or we going to round up to 63 cents. Because this is a 4, we rounding down. So we doing 63 cents. No, I'm tripping. I just said we rounded down. We round down to 62 cents. All right. So out of the 20 pack, one battery is 62 cents. That's one battery. One battery is 62 cents off that 20 pack. Now let's do the 12 pack. Now off the 12 pack, we got 12 over 720 is equal to 1 over X, because I want to know how much one battery costs, right? Again, Malcolm X method, crossing, 12X. Like I said, I like my variables on the left side, even though you can put yours on the right if you want to. And then 720 times 1 is 7.20. So 12X equals 7.20. All right, make sure you understand how I got that. I did 12 times X. I multiplied diagonally. Let me try that again. I multiplied diagonally. Look at where my arrows are. Look at my line. 12 times X is 12X. So the products of each of the diagonals goes on opposite sides of the equal sign, if you notice. Also, remember that too. 7.20 times 1 is 7.20, or $7.20. Now I'm trying to get X by itself. So the question is, how do you get X by itself? You get X by itself by doing division. Divide by 12, divide by 12. 12 divided by 12 is 1, you got 1X. So X is equal to 7.20 divided by 12. 0.6. Now this just say 0.6. But when we talk about money, we talking about change, it's less than $1. 0.6, we wouldn't just say 0.6, right? And see, a lot of people, well, let me write it down, because this is important. This is important. Because a lot of people will look at that on their calculator and be like, oh, 6 cents. Because all I see is a 6, so I think that's 6 cents. Nah, that's not 6 cents. That 6 is in the 10th place. That 6 is in the 10th place. And because that 6 is in the 10th place, that means that can also be expressed as 60 cents. That's 60 pennies, right? Because in the hundredths place is where the pennies go. In this place right here, in terms of place value, that's where the pennies go. The tenths, or like the dimes, right, go in this place. So that means that if there's a 6 in this place right here, that tells you how many dimes there should be. There should be 6. There should be 6 dimes. That's why it's called the 10th place. A dime is worth 10 cents, right? So when you see that, a lot of people, a lot of students, they look at that and they say, okay, well, I only see one number. I see 0.6. So if I see 0.6, then I'm thinking, okay, that's 6 cents. Nah, 6 cents is this. 6 cents is 0.06. Remember that. 6 cents is 0.06. The pennies go in the hundredths place. The pennies go in the hundredths place. The pennies go in the hundredths place. The dimes go in the tenths place. So if you see on your calculator 0.6, that means 60 cents. If you see 0.5, that means 50 cents. If you see 0.9, that means 90 cents. That don't mean 9 cents. Keep that in mind. That's a very common misconception that a lot of students have. I see it all the time. I've been seeing it for years. I've been teaching math for 17 years. I've seen it, right? I see it all the time. So that's why I wanted to take time and drill in on that. But anyway, these batteries are 60 cents. One of these is 60 cents off the 12 pack. One of these is 62 cents off the 20 pack. So therefore, the batteries in the 12 pack are cheaper. Now we could have figured that without even doing all this math. You know why? Because if the 12 packs were cheaper to buy to get 60, then it would make sense that buying one from the 12 pack would also be cheaper, right? Because one of these basically times 60 is how you get this amount. One of these times 60 is how you get this amount. So that's another thing we could have just thought of, right? But it's good that we showed our work and proved it. Because if I just said, well, I think the 12 pack is cheaper, and then I couldn't prove it, because math is all about proof. In math, you want to be able to prove what you're saying. All right, you want to be able to prove it. All right, so this is how we prove it. 62 cents from doing the algebra, 60 cents from doing the algebra. All right, now again, this is Eureka math. Problem D, grade 6, module 1, lesson 20. All right. Now, the key is use this video as a guide. Take this information and go practice. Do some more practice problems. And before I go, I forgot that I wanted to shout out Winston-Salem State University. It's a HBCU down in Winston-Salem, North Carolina. Shout out to Winston-Salem State University and all the HBCUs. All right. But like I said, yeah, this is just a guide. This is a guide. And if anything didn't make a lot of sense, rewind it, run it back and rewind it and try to make it make more sense to you. And then go practice. You got to do practice problems. If you don't do practice problems, none of this matters. You got to practice on your own. All right. So you go get some practice and I'll catch up with you on the next video. Peace.